Okay, let's get started. I'm Yong Shin from ETRI, South Korea. Today, we are going to talk about Chipmunk, that is a distributed object storage system for NDN. We've got our initial idea from RepoNG and wanted to further improve it to have better scalability and easy of user experience by hiding complexity under the hood. Users want to be able to use storage using only simple names regardless of where they are located. Chipmunks provide a common name that users can easily access. So every participating node has a common prefix as a service name besides its own prefix. The metadata storage system is distributed across the network, taking a DHT-style approach with keys as data names. Chipmunk nodes are clustered as ring using consistent hashing. The hash of each NDN name is different from one another, and the hash of the same NDN name is consistent. The metadata node is selected through the hash of NDN name that is chosen by a user. This means that the node responsible for the metadata is determined with the hash value and it is distributed across the network. This allows to find the correct destination without broadcasting or using a centralized systems like DNS. We got a lot of questions about using metadata from reviewers. In fact, it is essential in making a distributed storage service that users don't have to be involved in secure storage space. Chipmunk takes care of it and then maps user-given data name to the file that have been stored somewhere in the repository. Chipmunk is an object storage system consisting of a file and metadata storage. And it is implemented based on RepoNG, so it inherits the overall structure and command sets in RepoNG. The file storage of Chipmunk is based on ext4 file systems. It generates subdirectories and stores data packets using 2 characters from the hash of data name. This approach solves many of the concerns for developers who don't want to inherit the limitations from ACID properties from database systems. We plan to adapt user-friendly methods such as drag and drop or copy and paste. Chipmunk node also provide metadata storage along with the file storage system. The metadata storage is basically a key value store. It provides metadata that is mapped with the result of hashing NDN name requested by the user as the key. This is analogous to a simple yellow page or an NDNS. Let's take a closer look at the behavior and the demo environment. This demonstration shows data insertion and retrieval in the Chipmunk cluster. We will use Chipmunk tools based on RepoNG. We have 6 Chipmunk nodes. Each node have a common prefix /Chipmunk. First, the producer gives a data insertion request like this. NDN put file and common prefix is Chipmunk and NDN name is hello and file. And the Chipmunk node, which receives and inserts request, pulls the data through the exchange of interest and data messages and stores it in the file system. Like this, the node stored the data. And a metadata is created, and the node to store the metadata is chosen by a hash calculation of NDN name. So node 2 stored metadata. The request to store the metadata is delivered to the selected metadata storage node. Data consumers do not know which nodes have the data. Therefore, consumers request data using only the NDN name like this. NDN get file and just an NDN name, hello. Then hash of NDN name is used to locate the node where the metadata is stored. The metadata is provided from the key value store from the node that is responsible for the metadata. The data is requested to the node that stores the actual data using the information in the metadata. We are currently changing our prototype to adapt forwarding hints to increase flexibility and make it more efficient. Data producers can create replicas and other nodes after a storage request, like this. The node 2 stores only metadata file, and yeah. It means the same data can be requested to be stored in multiple Chipmunk nodes for various purposes, such as increasing availability. Now, the node 2 stored the data. The metadata for NDN name is updated when replication is completed and other nodes. When data consumers request NDN name, metadata is provided like this. NDN get file and NDN name, hello. The metadata received contains a list of nodes that actually store data for NDN name. The consumers can choose one of them and request data. We are planning to use this feature to provide load balance among Chipmunk nodes. Basic models such as object storage module, insertion, and retrieve command were carried out in phase 1. Now, we are currently proceeding with phase 2. Thank you very much for listening.